So you should be seeing it on Facebook already. We are also going on YouTube. So I'm going to try both at the same time. So right now on YouTube, it should be live already. So YouTube is via the OBS. Then Facebook is directly via Zoom itself. Okay, so I think everything should be in order already. Like I said, every week I'm trying out different things. So I'm hoping to be able to uh, get the hang of it. But to also just create this as much as I can. I want to increase the exposure as much as I can. It's live already. Awesome. Things should be in order already. Okay, so I seeing a lot of copies of myself. I see myself on Zoom, I see myself on Facebook, I see myself on my own Zoom meeting on my other computer, because today we had a little cock up today, a little hiccup, because I misplaced my Apple Pencil. Okay, so I'm unable to use my iPad to do my normal writing. But I came up with an alternative because I have a spare laptop with me, and before I bought my Apple products, I have been using my Windows laptop and a stylus that looks like this to help me to conduct my online lessons. Okay, so this is a very cheap stylus version. Don't blame me for it. It's just, if I'm not wrong, I bought this for $15. I bought this for $15, but it's still quite handy, as you can see from what we have now. Okay, so once again, welcome everyone to our weekly Quickfire Max today. So it will start officially at 5 p.m. and then it will be all the way until 8 p.m. So every week what I'll be doing is I'll be picking out random math topics to share with everyone, whether is it for your own revision, or whether is it for a lecture, or whether is it for people who want to listen ahead. Okay, this is for you. Because why do I create this weekly live session every single week? This is because I want to encourage and to celebrate the initiative of self-learning. So within my area of expertise, which is in mathematics, I try my best to provide as much free resources for people who really want to take their own self-initiative into learning. Okay, so apart from the daily schedules and my tuition assignments, I'm also doing this weekly live from every Thursday. Apart from that, I'm also setting up 2 Telegram channels. One is for primary school students and one is for secondary school students. I also have my own own WhatsApp group, which is more internal. Okay, because a bunch of secondary school friends wanted to to set it up and then interact among themselves, so I created a WhatsApp group as well. So apart from that, I'm also on Discord. Okay, so for those of you who are on Discord, you guys will also be able to see me as well. Okay, now let me try to adjust my streams a bit. Okay, I should be seeing multiple versions of myself. 1, 2, 3. Okay, so on YouTube it's fine. Yeah, everything is going. I'm seeing 4 copies of myself right now. Okay, so at the same time, like I mentioned, I'm also doing Discord. So for those people who are doing Discord, you guys can also come on in as well. Okay, at the same time, I'm going to just quickly do a shout out over there that I'm going to start my live. Announcements. Okay. Okay, and I also want to take this opportunity to go and I really want to like document this whole journey. So as I creating like multiple multiple methods to fill my own status and to make this whole setup happen. So I'm just gonna like do a quick filming. Also, for those of you behind the scenes and you guys have my WhatsApp contact, you guys will be able to see what the setup am I doing. Okay, And I also, before I started the quickfire session today, I actually went to quickly go and count how many sessions I did. And guess what? I did 11. I did 11 sessions already. There is like 33 hours. 33 hours of online sharing of maths. I think it's I would say it's an impressive feat as of now to be able to sustain. I hope that this is able to continue. Hope that this is able to continue on so that more people can actually come in and to benefit. Okay, like I mentioned, the topics that I'll be covering will be geared more towards on secondary topics, but of course if there are primary school kids coming in, sure, why not? I don't see reason why to reject them. So just come on in if you guys manage to see this by the power of big data. And now today we are actually going to push a bit more on the publicity side. Okay, so at the same time, let me just give you guys a quick update of what's happening right now. So for the past few sessions, I've been talking about this exam bootcamp, exam training bootcamp that is bound to happen in June. Okay, so what will happen is that every day I will be selecting a couple of papers. That means ranging from primary school to secondary school students. Okay, this June holiday program, right, the objective, right, is for graduating students to actually come over to give yourself an opportunity to do a time practice. Okay, it's a mock paper. So I want you guys, because I know that some schools, you guys have already removed the mid-year exams. So parents are actually looking for an opportunity to give their children a chance to actually gauge themselves in terms of ability. So I created this exam bootcamp together with my partner and my wife. So we are going to do it every day. It's not just every week. We are going to do it every day in the month of June. Okay, but of course every day we will be focusing on different levels and subjects Okay, so for the levels that we'll be covering, number 1, we'll be doing P6 mathematics, P6 science, number 2, P6 science, Sec 4 E-Maths and Sec 4 A-Maths. Okay, so P6 Maths and Science, and then Sec 4 E-Maths and A-Maths. These are the 4 topics, the 4 subjects that we will be covering in the June holidays. Okay, so it will start from the 1st of June and then it will stretch all the way until the end of the June holidays. So for parents who happens to see this, if you guys want to give yourself and your children a chance to actually gauge themselves during this June break, and then especially for graduating students, alright, come over and find out more from us. It's called our MAP exam bootcamp. Okay, so the fees wise, we have also confirmed already. So for our own tutors, for our own tutees, our own students, it will be $29.90 for each session. So you all can book multiple sessions of different subjects. All the subjects, all the levels will be the same pricing. Okay, so one session will be $29.90 for our own students. And then for the public, we also want to have public coming in as well. So for public that comes in, every session will be $59.90. Alright, so for our students, $29.90. For public, it will be $59.90. Okay, we have at the same time launched a promotion. Okay, so this promotion works like this. So I understand that we might be you guys will be booking multiple sessions because you all don't just come for 1 week. Maybe this week you all come for P6 Maths, then the other week you come for science. Okay, that works as well. Okay, so if you guys book multiple sessions, right, it will be a 10% off of the entire of the total amount that you guys buy So it will be based on the number of sessions, and then if you book 2 and above sessions, it will be a 10% off. Okay, so for tutees, it will be $29.90. For non-tutees, it will be $59.90. So I'll just do a bit of advertising here first because I also understand that parents and students wants to steer clear of the schedule, because I understand that schools sometimes have some supplementary classes or remedial classes during the June holidays. Okay, so I would like to put this out to everyone first so that the parents and students will be able to take a look at their schedule in advance and to make arrangements from there. Okay, so we want to really maximize the June holidays, especially for the graduating students. So what will happen, right, is during each of the sessions, let me just do a quick breakdown of what is going to happen in each of these sessions. So each session will be either 4 hours or 4.5 hours. Okay, for primary school students, P6 Maths and P6 Science, it will be 4 hours. For Sec 4 E-Maths and A-Maths will be 4.5 hours. So it will be either from 3 or 3:30 all the way to 7:30. No matter which session you pick, no matter which level you are at, you will end at 7:30. So you will either start earlier or start later. Okay, so what will happen during this each of these sessions? Allow me to explain a bit more. Okay, so for this so I take for example, so for a P6 student, that means the session is 4 hours. Okay, so what will happen is during the first 2 hours, you guys will be sitting down to do the mock paper. Okay, we will be issuing you a mock paper. So you all either do on the spot, okay, you all just do on the spot with us or online. Okay, for our duties, you have the liberty to choose whether or not you guys want to come over to our office here, or you all can do it online via Zoom. For duties, you all have the liberty to choose. But for public friends, you guys will have to come down to our place here at Tanjong Pagar. Okay, so during these 2 hours, you guys will sit through the paper. You all will take it as if it's a prelim exam or a mock exam. Okay, just sit through the paper, do it as if it's a real exam. Okay, so after that, once the 2 hours is over, you guys will go for a short break for about 15 to half an hour. 15 minutes to half an hour for us to actually make the arrangements. And then what we will do is, at the end of the 15-minute break, we will shift you guys to a meeting room, where in this meeting room, we will actually on the spot go through the paper with you. So for those of you who actually come down to the physical location with us, you guys will really benefit, because you guys will be able to see on the spot how the paper is being gone through, and to be able to see the teaching from myself and my wife. Okay, so this is what is going to happen for the offline people. That means those people who actually come down to physical locations. For those people who are taking the online option, okay, in fact, we are also considering to open up the public option to online friends as well. Okay, so for those people who are doing online, right, same thing. We will either prepare the paper for you, or we will mail the parents the soft copy, and then you guys will actually prepare and print the paper in advance. Okay, so once the 2 hours starts, you all can actually come in and to the Zoom meeting, and then we will invigilate you for the 2 hours. Same thing, go for the break, and then after that, when you all come back in for the second half of the part of the session, you guys will be able to sit through the going through part, where we'll go through the paper with you. For our duties, you guys have a choice to actually skip the second part of the lesson, because we will be able to actually go through the paper with you during your tuition sessions, during our regular tuition sessions. But for those of you who are not, okay, I will highly suggest and recommend you guys continue to stay in the Zoom meeting, so we can actually go through the paper with you during the online session. Okay, so offline and online will be done concurrently. Okay, so for those people who are actually coming down to our physical office, you guys will actually see on the spot live. That means it's really like a lesson, or you can say a lecture whatsoever. It's like a session where we will actually go through the paper with you. For online people, same thing. So it will be conducted hybrid. Okay, so I say again, you will start from the first week of June, and then you will go all the way to the last week of June, where the June holiday ends. Okay, so what else I need to top up on this one? Topic. Okay, so I say again, the subjects will be P6 Maths, P6 Science, Sec 4 E-Maths, Sec 4 A-Maths. So every day we'll be doing different papers. If I'm not wrong, the schedule should be out very, very soon. Okay, we have already confirmed that which day we'll be doing which paper. Okay, so for example, for secondary school students, you need help, or you need an exam in both your E-Maths and A-Maths. Okay, so you all can go for, and maybe we have also broken down to paper 1 and paper 2. So one day we'll be doing A-Maths paper 1, A-Maths paper 2, E-Maths paper 1, E-Maths paper 2, and then P6 Maths, P6 Science. Okay, so we will have different days for different things. Okay, there will be one day which is on the Saturday. Okay, do take note for those of you who are looking for the weekends. Okay, for the weekends, maybe in the weekdays you guys have something on, like school have supplementary lessons and so on and so forth. If you guys are looking for weekends, I'll be doing P6 Maths, and then my wife will be doing P6 Science. This is an opportunity for you all to come down to our office here. Okay, so we'll be doing it in the morning. Saturday we'll be doing it in the no. Saturday I also doing it in the afternoon. Yeah, also in the afternoon, correct. Okay, but Saturday, let me confirm on this again. But Saturday we will be doing a half day. Most likely it should be in the morning. Yes, Saturday in the morning. Saturday in the morning. So those of you who are looking for Saturday morning classes, right, that is the best time for y'all. Okay, otherwise y'all can just continually take a look at our schedules. We will be releasing it to our major channels, mainly our Discord, our Telegram channels, our Facebook channels as well. And also we have also recently set up an Instagram page. We will be releasing more news over there as well. Okay, so we will try our best to actually give you guys as much resources as much as we can. So this exam bootcamp is going to be a very important milestone, especially when starting from next year, okay, the P6 students are going to enter the full SBB system, subject-based banding system. Alright, so in order to better gauge where you are right now, this is the best time for you all to actually take advantage of this bootcamp to gauge for yourself where and how ready are you when it comes to PSLE at the end of the year. Okay, so this exam bootcamp I shall leave it as here. So more details we will update you guys every week as I do the quickfire. Okay, so back to the quickfire. I'm very happy to be here once again. So 11 sessions and counting. So along the way, we had quite a lot of discussion for a couple of topics. So if you guys want me to actually revise on any topics that I covered previously in the previous sessions, do let me know as well. I'm also able to do so. Or otherwise, I'll continue to pick on random topics that has not been covered previously. Then we will continue from there. Of course, like I mentioned, the same rules apply. I'm actually doing this on a Zoom meeting. So if you guys actually see me teaching halfway and then suddenly halfway through some random Zoom person comes in, that means they have the link access and then they come straight into my Zoom meeting, then I will actually prioritize those people and their questions. Okay, so maybe there might be a divert in the topic itself, but otherwise I will cover one topic throughout to the best I can. Okay, can. Let me also at the same time do a quick shout out to my WhatsApp group as well. So of course on YouTube and on Facebook, whoever that is online and managed to see this, if you want me to go through any specific topic or any specific question type, do let me know as well. I'm ready to look into all the comments from all the different platforms. So if you guys actually manage to see this and you guys want to really interact and to utilize this time to do a revision on your own, or maybe with a couple of friends, maybe you guys at library, or maybe you guys in school, you guys chance across this channel, then feel free to interact with me and ask me anything that is regarding your maths. Okay, maths homework maybe not lah. Okay, but I can provide you with some tips. Okay, that will work as well. Okay, I understand that a lot of there was a lot of feedback previously asking me why am I doing this on a more freestyle basis. Okay, personally I feel that it is more mutual. Number one, it's more mutual. Number two, I'm trying to do something different here. Okay, I know that there are a lot of tutors out there who are doing the same thing. That means they prepare a preset of topics and then they will just go through, they prepare questions in advance and then they will just do in advance. So they prepare a whole list of schedules. So every schedule, maybe 2 weeks ahead, what topic they will cover, 3 weeks ahead, what they will cover. That is something that I'm trying my best not to do, because I want to make it a more informative one. Like I said, if there's no one asking any questions, there's no one coming in, I'll just continue on to share random topics like what the other tutors are normally doing. But I want to make it a more interactive one. So if you guys got questions, you guys ask. The more you guys ask, the more you guys will learn, the more I will share, and we will all interact and learn together. Because I always believe and I always tell my students, it's always a mutual learning process. It's not just me It's not just me coming down to tell you guys, hey, what to do, so on and so forth. Okay, but however, it's more of it's more on, how to say, it's more on helping you guys to, learn. You guys have questions, you guys ask. I think that is a more effective method, I feel. Okay, suddenly my live stream stopped. Okay, yeah, my live stream is still ongoing. Okay, let me just push the link out again to those people who are here. Where's the link? Okay, let me just quickly push the link out to my guys. Okay, of course, if you guys got any questions or have any comments or whatsoever, you guys please feel free to let me know. Okay, I'll be more than happy to let you guys. I got friends asking me about number theories and combinatorics. Number theories and combinatorics. So basically, we are talking about things like probability. We are talking about things like our n choose r binomial theorem and all that stuff. So that is quite an upper secondary A-maths topic already. So if you guys got any lower secondary topics, you guys can let me know also. If not, I will be talking to this guy already. Okay, so do let me know if you guys got anything that you all want me to go through. Okay, so if that's the case, if you are talking about combinatorics, we got, okay, so what I will do now, since we have a selected topic that we are talking about already, so I will just shift everyone over to my share screen, to my whiteboard. So I will doing my Zoom there. Okay, let me try to change the stream. Okay, because like I said, I'm using an external software, so I need to make sure that everything is in the working order. So I need to off this. Do I off this? No, I change it to front camera. Okay, I change it to front camera, and then I do my share screen over here. No choice, I have to do all this. Okay, now it should work. Okay, I'm seeing myself already, but my YouTube seems to be lagging. Is it correct? Let me try again. Video capture device. No, that's what I'm looking for. Screen capture. Okay. Okay, I think yeah, let me just quickly do a bit of changing for my YouTube side of things. So if I will hide this out, oh no. Okay, let me just, okay, it's up already. So let me just bring my camera to the front for those people who are watching on YouTube. For those people who are watching on Facebook and YouTube, Facebook and Zoom, you guys will be able to see everything normally. It's just the YouTube part because I'm using an external software. Okay, good. I think my YouTube is up as well. Awesome. Okay, so in the meantime, while waiting for the guy to come in, I'll just talk a bit about this thing called combinatorics then. Where is my pen? Okay, to be very honest, the spelling for this part is actually very, very difficult as well. Wait, I try my best. Because right now I got an issue. I can't find my pointer. Okay. Wow, this is a high level. Combinatorics. Okay, combinatorics basically is to just calculate the number of permutations and combinations. So it's just P and C. Okay, or not P and C as in private and confidential, guys, but it's more like confidential. No, private and confidential is permutations and combinations. But of course, permutations is something that is being learned only in junior college. So we don't really talk about we don't really talk about permutations in the secondary school level, but we talk about choosing. That means combinations. C, that is something that is still quite commonplace in secondary school A maths. Okay. Okay, combinatorics. Okay, I'm having trouble finding my pencil over here actually, so I need to gauge where am I. Okay, because no choice, I'm actually using the screen over here. Okay, let me try to actually see this if it works. Oh, this is quite okay. Permutations. Combinations. Okay, so this one, there's a couple of topics that is on under this topic of combinatorics. So I will want to go through a bit I don't want to go too in depth for that. Number one, probability. That's the first one. Number two, I have my binomial theorem. Oh, my handwriting is going to be very ugly today because I can't see my cursor. So I'm trying my best to see if you guys will be able to catch. Otherwise it will be quite messy from here. Like I said, I'm trying my very very best to write it as neatly as I can. Okay, so for combinatorics, the best way to introduce this concept to you guys is through this topic called binomial theorem. Oh, I can see my cursor already. Yay. Okay, so maybe I just use this ink. Okay, maybe wait. See, I can change it to blue. So if I write it in blue, okay, can I see it? Ah, yes, I can see it. If not, it'll be red screen and red words all over. Looks quite scary. Okay, I try my best. Okay, so binomial theorem. Binomial theorem is something that is on. I think I mentioned it one of my sessions before. A few of my sessions before this session today. So I would say you all can actually go back to visit my previous sessions. So to those of you who want to find where my previous sessions are, they are on my Facebook. Okay, so I know that most of you don't have my personal Facebook. I'll try my best to actually bring those videos to YouTube, and then I'll do some chaptering over there as well. Okay, so also just a quick shout out as well. Last 2 weeks I did my first YouTube stream. So for those of you on YouTube, right, when you go back and see the screen, right, I have already did my chaptering. So you all can, I put in the timestamps where you all can actually click into the different segments and to just hear the specific segments of trigonometry. Okay, so for those of you who are looking for trigonometry, I already covered it. Okay, and it also gives me a good way to document what are the things that I covered lah. So in case you all need some revision, I always bring you all back there, and maybe I'll just take a video and then put it back here again. Okay, can. So that is for the trigonometry part. So today let's talk a bit about binomial theorem. Okay, binomial theorem. Wow, this one. Okay, so for binomial theorem, okay, you'll be facing a lot of different types of questions. Find the general term. Okay, so maybe I'll just sum it up by sharing you guys what are the kind of general terms that you guys see. Okay, number one, general term. Before you guys go into definition, let me just run through what are the terminology that you guys see first, okay? Then you all see this n choose r. Then you all will see things like factorial. Again, with the exclamation mark there, because it's in a mathematical jargon, exclamation mark is being used for factorial. Okay, general term, n choose r, factorial. Okay, we have also things like independent of x. Okay, independent of x. So these are the general things that you all will see. Okay, at least you all get to know the terminology first. And then we talk about the ascending powers of x and descending powers of x. Okay, let me just reply to this guy first. Okay, independent of x, ascending and descending. Okay, so let's talk a bit about the beginnings of binomial theorem. So basically, this binomial theorem, right? In short, what does it mean and where does it come from? Because in school, what you guys heard of binomial theorem is where you guys learn about Pascal triangle and then you all just go with the number, general term like that. I want to spend a bit more time into the origins of binomial theorem and how does it relate to what you guys are doing in school. Okay, so I'll just erase all this first. So these terms are the general terms. You guys will actually see more of it later. I try to cover as much as I can, but I understand that I may not be able to cover everything, so pardon me on that. Okay, so binomial theorem actually comes from this thing called binomial distribution. Okay, and binomial distribution is one of the main three distribution models that we see in today's world in terms of economics, in terms of statistics. Okay, so this is the first one, binomial distribution. The second one will be the normal distribution. And the last one will be called Poisson. Okay, so there will be three distribution models. Okay, so what you guys are actually focusing on right now will be binomial. But the binomial part, right, is only on the theorem itself. That means how the numbers is being used itself. And we won't go so much into the statistics part and the distribution models and all these things. Okay, in short, what are these distribution models? Your bell curves. Okay, when I say about bell curves, some of you may ring a bell. Bell curve. Okay, like when y'all go for exams, y'all pray to the bell curve god. Hopefully y'all get an A because everyone else don't. Okay, things like that. So bell curves, binomial, normal, and Poisson distribution should come to your head. These are your different distribution models. Okay, but binomial distribution, and generally when you talk about bell curve, when I talk about bell curve, everyone should know how in generally it looks like. Okay, it will look like this. Okay, it's not a very good graph. Let me draw again. It will look like this. Something like that. So this is so-called your bell curve god. Okay, so in fact, all of these three distributions follow this model. Okay, just that the statistics are different, the metrics are different, and how are they being distributed. And depending on the sample size, depending on what is being tested, depending on the error margin, the statistic and the most suitable distribution model will vary, depend on the different situations. Okay, so basically, let's go back to our binomial theorem. Okay, just need to know that it all comes from binomial distribution. Okay, binomial. So I just put in the concepts here now, okay? The second thing that we need to learn is called the Pascal triangle. Why is it called Pascal triangle? Because this triangle is being invented or founded by this guy named Pascal, obviously. And for those of you who are studying physics, Pascal is also the unit, standard unit for pressure, PA. Okay, so for those of you who knows and studies physics, Pascal shouldn't be very new to you. So he is the same guy that also created this Pascal triangle. So basically, how does this Pascal triangle works? Okay, very interesting model. Let me just quickly bring you guys out. So I zoom out a bit more. The good thing about this one is that it can actually zoom in and out, so you all can actually see. Okay, so for Pascal triangle, how does it really work? I'm trying to, can I shift this around? Can I shift this away? Oh, looks like I can't. Okay, oh wells. Okay, so I'll just try my best to write. Okay, so for Pascal triangle, it works like this. Okay, as you know, triangle, there must be a tip. Okay, the tip always starts with a 1. And then the second and third numbers will be both 1s as well. Then followed by 1, 2, 1. 1, 3, 3, 1. 1, 4, 6, 4, 1. 1, 5, 10, 10, 5, 1. Then it will go on and on and on for indefinitely. Okay, so basically, how does these numbers actually come about? If you take any of the triangles, look carefully, this is very interesting. So you see, how does this 2 come about? This 2 comes about where it is the sum of the 2 numbers coming from the top. Okay, so here you can see 1 plus 1 gives me 2. And then if you look at 3, I use another color. If I look at 3, it's actually made up of 1 plus 2, that gives me 3. Same thing for the 3 on the right hand side. So it will be 3, it means it's 2 plus 1. So as you can see, all the numbers at the bottom right is being made up of the sums of the on top 2 numbers. So for example, I got my 10. 10 means 4 plus 6 lah. Okay, so like I said, these numbers can go big and big and bigger and bigger. So it will go indefinitely as long as numbers exist. Okay, so in short, this is the Pascal triangle. So how is this Pascal triangle useful in our subsequent sums? Okay, let's recreate this Pascal triangle later on when we try different questions. But for now, let's just appreciate the existence of this Pascal triangle and move on first. Okay, so Pascal triangle. Okay, number 3. The third thing that I would like to talk about is your recap. Recap on what? Recap on your 3 sacred lines. You see, I've been always harping on the same thing. The 3 sacred lines, the 3 sacred lines, the 3 sacred lines. Okay, so what are the 3 sacred lines? The 3 sacred lines refers to your algebra identities. Okay, so I try to zoom in here. See if I can zoom in here. Awesome. Okay, so algebraic identities. Okay, so the first line, a plus b squared equals to a squared plus 2ab plus b squared. Second line, a minus b squared, a squared minus 2ab plus b squared. 3, a plus a minus b, a plus b equals to a squared minus b squared. Okay, so this is something that we have always been harping on to memorize. But today, let's focus just on the first 2 lines, line 1 and line 2. A plus b whole thing squared equals to a squared plus 2ab plus b squared, and then a minus b squared equals to a squared minus 2ab plus b squared. Okay, now here's the interesting part. Do you see that right now, we just focus our eyes and attention on the coefficient itself. If we look at the coefficient itself, do you see something very interesting? It's actually 1, 2, 1. 1, 2, 1. Do you see very familiar? Or we have found this combination somewhere? Yes, for those of you who actually saw it, it's actually in the Pascal triangle. Okay, so once again, I'll recreate the Pascal triangle on the right hand side. Oh, wait, hang on. I'll recreate the Pascal triangle on my right hand side. so you guys were able to relate. Okay, so 1 1 1 1 2 1 1 3 3 1. Do you see that on the third line it actually coincides with the coefficients of the algebra identities? You see that this is 1 2 1. Okay, this is 1 2 1, and on the third line it is 1 2 1. That is precisely, in fact, how we managed to get the algebra identities is exactly from the Pascal triangle. It's just that Pascal triangle extends it further to give us the coefficients for bigger things. Okay, that's all we need to know for now. Okay, so interestingly, how does it work? Basically, coming back to this Pascal triangle, what it means that for the first line, which is 1 1, is actually referring to x plus y. That means two variables. When you have one count of each variable each. Okay, the other one will be on the, so the second line over here will be x plus y square. And from here, can we actually infer that the third line actually comes from x plus y cubed? So with this new introduction and a new inference of x plus y whole thing cubed, we have come officially to this whole topic called binomial theorem. So in short, what is binomial theorem? It is allowing you to expand on algebra expressions like this with when the powers are more than 2. That is where we use binomial theorem. Okay? Because a squared plus 2ab plus b squared, we have been using it many times from sec 2 all the way to sec 4. But from binomial theorem, this is something new. Because what happens if the power is 5? What happens if the power is 10 or 12 or 20, 17? We can always go back to the binomial theorem, and there's a fixed formula for us actually to find what we are looking for. Let's come back here. Okay, so this is an overview and the purpose of binomial theorem. Let's come back to the identities and the 3 sacred lines. 1 2 1. So in short, each of these, right, because the identities is already the end product, we must understand what is the original derivation of a plus b squared that allows us to get a squared plus 2ab plus b squared. So I'll just take the first line, for example, since it's easier and all of them are on plus sign. Let's make it easier. Remember back then how we actually found out that a plus b the whole thing square is this line that we get? Okay, if we were to do it like this, it's actually a plus b multiplied by a plus b. Then what we do and what we normally learn, we do the rainbow, right? We go and multiply term by term, correct? ab plus ba plus b squared. Then you realize that, oh, the middle two are like terms, so a squared plus 2ab plus b squared. Yes, that works as well. That is the original way to do it. However, if there are multiple terms, like for example, a plus b to the power of 3, essentially is equal to a plus b, a plus b, a plus b, because anything cubed means the term is multiplied by itself 3 times. Okay, we need to understand and to always remember that. So a plus b the whole thing cube is a plus b times a plus b plus a times a plus b. So actually, if we were to do everything itself, everything term by term, we got to do a lot of things. We got to do first term, which is a cube, and then you got to do it multiple times. Okay, it's going to be a very lengthy process. I'm not going to continue, but I'm just going to show you guys what is the general term for each of these expansion terms. Okay, so back then, you see, I keep using the general term, expression, expansion. Okay, so once again, a small recap. In this term over here, in this line over here, and in this, let's zoom into a squared plus 2ab plus b squared. There are 3 terms. 3 terms. This is the first term, second term, and third term. This is just to recap, but of course I know most of you all know lah, okay? Because later on when we talk about general term, the n term, the 15th term, then we got a lot of numbers that's popping out here and there, then you got a few thousands and all these things. Yes, thousands are coming your way, okay? So we need to be very clear of what we are focusing on, okay? So that I don't lose you guys. Okay, so from here, a squared plus 2ab plus b squared, there are 3 terms. Okay, so in the questions of binomial theorem, they might ask you that, okay, find the 8th term. Then you go and find using certain formula. Okay, so now here's the thing: how to find the general term. Okay, now we are done with 3 sacred lines. We are done with the Pascal triangle. Now let's talk about 2 more things. Okay, number 1, general term. And number 5, n choose R. This n choose R thing is a brand new concept on combinatorics. This is where the first instance of the concept of combinatorics actually come into the picture for secondary school students. Okay, so for general term, let me show you guys the outline of a general term first. Then we go into n choose R, because general term involves the use of n choose R. So the general term looks like this. You all just need to copy down and then look at the format itself. Later on, we will bring in the whole thing together. Okay? Let me try to shift it somewhere else. It's been a while since I used this interface, so let me try. Let me just put it here. Okay, right below the 3 sacred lines. I'll try to use another color if possible. Okay, this is good. Maybe I'll go a bit thicker. Okay, general term. Important this one. Okay, note this down. Whenever you have a plus b, I'll use a plus b as a common term. And then you have a power of n. So what happens? Look carefully. So first one will be n choose 0, a, n, b, 0. Followed by n choose 1, a to the power of n minus 1. Okay, let me try to shift this aside also. b1 plus da, da, da. So you see that there are some numbers that increased. For example, the number below the c actually increased. There are some numbers that decreased. Oh, 2 numbers that increased. Number 1 is the number below the c and the power of the second term, which is the b. See? From b to the power of 0 becomes b to the power of 1. There are some numbers that actually went down. On the other hand, the power of a went down. Okay? So this will continue on and on and on until where the number below the 0 will keep increasing until it reaches the value of n. Okay? In this case, the last one will be n choose n, where a will decrease all the way to be 0 and b to be n. So you can see that this will be a whole lot of different things. Oh, sorry. A whole lot of different things. So the number of terms is determined by the power itself. Okay, it will be determined by the power itself. So for each of these terms, like I said, these are still individual terms. I want the general term. General term is what? Okay, so the general term looks like this. We just take the common format. N choose R. A is n minus R. B, R. This is my general term. That means, right, the value of R may change depending on what the question is asking for and depending on what is the power you're looking for. But in any case, this is the normal, this is the general term. So along the way, what happens is that the power of the first term, which in this case A, will actually go down. But the power of B will actually go up. Okay, so you can see that the change in powers is one goes down, one goes up, like this. Okay, so very important. So as I want to highlight the different terms for you to keep in focus. Okay, I just highlight the A, all the way to A to the power of 0. Okay, at the same time, I'll change it to B. I want you guys focus on B. You guys, this is for you all to see the contrasting difference where the power of A goes down and the power of B goes up. Okay, can you all catch that one? This one quite important. Okay, so this is the general term. At least you all know what the general terms is first. Okay, so now let me move on. Now we got this little, not so little thing called N choose R. What's this? Okay, N choose R. This brings us to the first concept and the first exposure of combinatorics. Okay, I'll leave the general term here. We'll come back to that in a second, but I need to go back to actually understand, let you guys understand what is N choose R. Okay, just bring it over to the, bring it over to the other side. Let me find a good place to do it. Okay, let me just do it at the side. The good thing about this whiteboard is it can stretch on infinitely, and then I can just zoom in as and when I want. But the bad thing is that my HP laptop, the touchpad is very small, so I need to try my best on this. Okay, just here. Okay, I just do it here. N choose R. Okay, so when it comes to N choose R, I just write the full term. N choose R. Okay, it can also be written as a bracket with an N and R inside. It looks a bit like vectors. Okay, it's not to be confused by vectors. Okay, or the direction vector or the vectors you all learn in Emacs is different. This is just N choose R. It's just a different way of writing it. Personally, I prefer writing it in a bracket term. Okay, because it looks nicer. Okay, and it's kind of unlikely to confuse this with vectors, so just keep it as it is. Okay, so essentially, what is N choose R? Okay, N choose R means, okay, so I say what is the definition? It equals to the number of ways or possibilities for R number of objects chosen given N objects. Memorize this. The number of ways or possibilities for R number of objects chosen given N objects. The number of ways or possibilities for R number of objects chosen given N objects. It looks very complicated, like a bunch of mouthful of things. Okay, but what exactly is this? If I use an example, it will be very easy to understand. Okay, so if, for example, if they say 5 choose 2, it can be any number, but however, very important thing is that the bottom number R should always be smaller than the top number N. Very important. It's unlikely you all will go wrong because you guys are not creating from scratch. The function is just there, N choose R. So just use it, okay? So it's just to let you guys know that the value of R should never go past N. Okay? Never. So basically, back to 5 choose R, what exactly does 5 choose R means? 5 choose R means, for example, today I have 5 shapes. Give me one more shape. I got 5 different shapes: a triangle, a square, a circle, a rectangle, a trapezium. There are 5 objects. So my question is, how many different possibilities are there if I were to choose 2 shapes out of these 5 shapes? I can choose the triangle shape, triangle and circle. I can choose triangle and square. I can choose trapezium and rectangle. So I just named 3 ways. So how many ways are there to choose 2 objects out of the 5 objects? So it's the number of possibilities to choose 2 objects given 5 objects. So in this case, my R is 2, my N is 5. Okay? Can. So take a while to sink in on this one. So basically, I'm just counting how many ways are there. Okay, so obviously, when the numbers, in this case, you can manually count lah. If you manually count, and then in the end, you'll realize that there are 10 ways to do so. Okay, there are really 10 ways to do so. Okay, but however, when the numbers get bigger, are we really going to count like every single stance, every single instance, every single possibility? Are we going to count and manually account for everything? No. Okay, so for such numbers, there are 2 ways you can look for the answer. That means the value of 5 choose 2 or whatsoever the choosing function is. There are 2 ways to do it. For small numbers, like this, or you can say small n values, where n is less than 5, where n is less than 5, there's always the Pascal triangle for you to fall back on. Okay? For bigger n values, where n is more than 5, there's always a calculator. There are 2 ways to do it. Why do I mention about Pascal triangle specifically when you know that everything can use calculator? Why use Pascal triangle? It is for efficiency and speed. Like I mentioned in my past quickfire sessions, I always emphasize about speed and accuracy. So there are some things, if you can memorize, that will be the best. Okay, otherwise you can always fall back on calculator. Okay, so for example, it's already ingrained in my head that 5 choose 2 is always 10. Just nice is twice lah. Okay, just nice. Okay, just nice. Okay, and also 5 choose 3 is 10, because I know that for my Pascal triangle, it comes from the line 1, 5, 10, 10, 5, 1. Later I'll let you guys know how to actually relate this Pascal triangle to solving small values like all this. Okay, so 1, 5, 10, 10, 5, 1. I'll leave it here first. Later on we'll come back to this one. Okay, so coming back to n choose r. There's a bit more of things that we need to talk about. So basically, we understood that n choose r means the number of possibilities to choose r objects given n objects. Okay, so apart from using the calculator, apart from using the Pascal triangle, there must be a way to actually manually calculate, ma. Okay, whether is it for big numbers. Back then there was no advanced calculator like this. So how do we do it? How do we do it manually? Okay, give it a guess. Yeah, I'm just doing some shameless advertising quickly. Okay, so oh, someone's coming in. Sure. Okay, I'll just sum up for this little part first, and then I think this guy coming in is from a sec 2, so he has some questions. Okay, later I'll help you about it. Okay, so for those people who are back on here, so for n choose r, for small n values, for n less than 5, you guys use the Pascal triangle. For bigger values, you guys can actually use the calculator. But how do actually people use it manually? Later on, I'll introduce this concept called factorial. Then, this is actually very rarely tested in exams, but it is still a common tool and is a must know for upper secondary students. Okay, So for those of you who just came in, you all can actually just drop me a message in the chat, a Zoom chat, and let me know what are the questions that you guys want me to cover. Okay? Wait, I just open up my chat first. Yes. Okay, I'll just prepare a separate board first. The good thing about this board now is that I can just zoom in and out infinitely. So yeah, just ask away. Or you want to use the mic? Also can. Hang on. Okay, I got his question already. Okay. For you who just came in with the question, just continue sending in. Okay, I'll just go through along the way. Okay, so this guy asked me on a bit about factorizing. Okay, 6x squared minus x minus 15. So he's not sure on how to put the multiplication frame on it. Okay, this is the reason why I don't do multiplication frame. Okay, for such questions, okay, there are certain ways that we can do it. Okay, I covered in the last week. If your coefficient for x squared, if your if your a is equals to 1, you can use the observation method. Okay, for a that is more than 1, you can actually use this thing called the CR method. Okay, this CR method, previously I haven't really got a chance to cover it because it's so-called my secret method. But let me teach you guys how to do it. I mentioned it before in my couple of lives back then. This is called the CR method. In short, the calculator reverse method. Okay, you are online, right? So do listen up. So do take out a calculator. I'm going to teach you how to use the calculator method and do it reverse. I'm going to ask you to reverse it. Let me know when you're ready. This CR method is very, very powerful, especially when you got all sorts of different types of equations and things like that. Look. Okay. But in short, while he's preparing, so right now our teachers are actually teaching this multiplication frame for Sec 2 students. They are actually supposed to go and guess certain numbers. Basically, you are still doing the guessing game while they are doing the guessing of numbers and factors and put it inside. Okay? But in this case, I always get them to use the calculator reverse method. Okay? So how do you guys use the calculator to do the reverse thing for you? Okay, basically go to your mode settings. Okay, mine is using Sharp, you guys are using Casio. Most of the time it's with Casio. Look for the mode button and then look for the equation. My equation is 2. So press on the equation, right? And then you see on my left hand side here, it should be a quad. Okay, quad stands for quadratic equations. Press 2. So you all will get a place, right, where you all will key in 3 values. There will be a B, and a C. A, B, C. So for A, B, C, right, key in the coefficients for your equation. So basically in this case, 6x squared minus x minus, I can't find it for Casio. There should be a way to do it. Is there a mode thing? There should be a mode lah. I don't have a Casio calculator. mode and then quadratic. Don't have. Cannot be. Cannot be. Okay. Let me just quickly let me quickly go online and then let me go and find a quick interface of the Casio calculator that you guys are using. Casio Singapore approved calculator. Is yours with the yellow button? I understand yours is the yellow button, right? The new Casio calculator that is able to scan the QR code one. Is that what you're using? The one with yellow numbers? Okay, gotcha. Okay, let me just quickly go and find the Casio. Or you can look for me, or you can let me know what is the model number of your Casio calculator. This is a very important feature. Wow, lucky you guys asked now. This is a very, very important one. You find the model number of your calculator and then send me. It should be printed on your calculator lah. Okay. Oh, got it. FX97SGX. Let me see the calculator. This one. I just need an image of it. Okay. Got it. Okay, what is on your calculator? You press menu. That means the menu, right, is beside the on button. You press menu, and then you should be able to see something called equation. The equation should be X is a 1, 2, 3, 4. There are 5 options over there. You navigate to one that's called equation. Do you manage to get it? Okay, once you press the menu, you should be able to look for the equation option. I think it's to press equals to go inside. Okay, after you all press equals to go inside already, right? You guys will be asked to key in the degree. The degree of the polynomial. This is where it gets interesting. Okay? Do you manage to get it? To get the screen? Then they will ask you this thing. Polynomial, very good, polynomial. So you all will see polynomial, and then you all will see degree. Under degree, what is degree? Degree is the highest power that you see in your polynomial. In this case, 2. So degree, right, you press in 2. Okay, and then you will see something like this. Ax squared plus bx plus c equals 0, and then it allowing you to key in the values for a, b, and c respectively. Do you manage to get it? Okay, this is a good question for me to do the CR method. Okay, there are some questions that is so simple that you don't even need a CR method. But in this case, this is a good one. Okay, do you manage to get it? Hey, awesome. Okay, so after you key in 2, you key in the coefficients for the different things. So A will be 6, B will be -1, and then C will be -15. So it relates to your coefficients of what you see in the question. This can be used for any sort of quadratic equations that you all will normally see in the other questions. Okay, after you all key in already, right, you all will actually get 2 things. You all will get, ultimately, right, you all will get 2 answers. Very interestingly, you will get 2 answers. Okay, one is, okay, so they will show you 2 answers. Okay, maybe you can let me know what is the answer that you see at the end of this. So that means you press all numbers already, you press equal, and then you press equal again, then it will show you 2 values. Because quadratic equations have either no value, 1 value, or 2 values. In this case, it's 2 values. What are the answers that you see? Okay, let me know what do you see in the calculator. Okay, for those of you online, take this time to take it as a lower secondary revision. Do you see 2 numbers? I haven't end yet. You have to put it back in the multiplication frame. This is not the final answer, guys. It's not the final answer. You are only being tasked to factorize. This is not your final answer. Okay, so we have one equation that is they say that x1 equals to 5/3. That's the first one. Then you press one more time, you get x2. What do you get? Yes, you get -3/2. So basically, back to this thing. How to now this is the answers that you get from the calculator. Now is the reverse method. You see, just now I said calculator reverse. That means there are two parts. One is the calculator part, one is the reverse part. So basically, how do we reverse and get this answer and get back to our factorized form? Because what we are looking for is the factorized form. I'm not looking to solve the equation. I'm only looking to factorize it. Okay, so from here, how do we see? Very important this one. So you got 5/3 and -3/2. So basically, as we all know, I bring down the equation here again. 6x squared minus x minus 15. As we all know, quadratic, that means we have two linear factors. That means we put a bracket here and here. Very important. Let's look at 5/3 first. So for 5/3, how do we put it back into the factor? Very important. Very important. Look carefully. The denominator goes in front. And then the 5 is the second term. Second term of the first expression. And then you see this answer 5/3 is positive, right? You change the sign. You put negative. 3x minus 5 will be your first factor. So I say again, the denominator x, then you change the sign, then the numerator. That accounts for your 5/3. Okay? Then for -3/2, how do we do it? Okay, maybe you can give it a try using the same idea. The denominator put in front, and then the x, then change the sign, then put the numerator. What do you get? Just follow the same idea. Yes, 2 plus 3. You got it. But of course include the x lah, okay? Yes, this is your factorized form. Okay? Of course, how do we rewire it back to the working? Okay? FYI, this CR method is a very powerful but a very unorthodox method. Okay? The schools will not allow this. But we need to show them the working that we are doing cross factorizing. Okay, so I know that there are ways to do it. One is the cross factorizing, one is the multiplication frame. For multiplication frame, okay, I show for cross factorizing first. It looks like this. Then minus x ma. So you write 3x minus 5, 2x plus 3. Then you cross here. Then you get minus 10x plus 9x. This is your answer. Okay, do you learn it this way? Previously I think I saw your working. Yours is actually looking like this, like that, something like that. So you got 6x here. Then in a way you break it up here, and then you got minus 15 here, if I'm not wrong. Something like that. But I'm not very proficient in the multiplication frame method. I'm more comfortable in the multiplication cross factorizing, which is like that. Yeah, I think you guys actually get the same thing. Can I understand already? For this one. This method works as well, guys. This method works as well. It's called the cross factorization method. What about the same equation but with a 0 at the back? Good question. Now we are depending on what you are asked. Okay, so this person asked, what about the same equation but with the 0 at the back. Okay, this boils down to the difference between an equation and an expression. From the very first day I talked about it already. The difference between an equation and expression is when equations you can solve for the values. That means there's an explicitly exact value of x that you need to find. But in this case, just now from the first question, you are telling me, it depending on what the instruction is. If the question tells you factorize 6x squared minus x minus 15, this will be your answer. However, if now you are telling me to solve the equation, so that depends, it must really look out for the instructions. If it says solve for 6x squared minus x minus 15 equal to 0, that means this thing that you factorize is equal to 0. So in this case, it is either, because since the product is 0, that means one of the factors must be 0 lah, correct? But I don't know which one. So it's either 3x minus 5 equals to 0 or 2x plus 3 equals 0. Okay? So from here, I go and solve for the value of x. In this case, you have conveniently solved it already. Why? Calculator. Because your calculator has already told you what the values are. So if you are looking for solving, that means there's an equation at the back. 6x squared minus x minus 15 equal to 0. These two values would be your answer. But if they ask you to factorize only, that means there's no equation sign. There's no equal sign. If there's no equal sign, then the factorized form, this one will be your answer. You see the difference here? It's two different things. It's two different things by using the same method. Two different things by using the same method. Very important here, very important. Okay? So always differentiate between the expression as and the equation. 我从第一天已经讲了，这个是很重要的，很重要的，一定要用。Okay? So always look out for instructions, whether they ask you to factorize or whether they ask you to solve. If they ask you to solve, that means it must have an equal sign. That means there's an x value that takes in the equation. Can you understand? Can you understand? Because sometimes when they ask us to solve, it may not be so direct where they equate to 0 all the time. Sometimes they equate to another number. Then you got to do some manipulation until it equals to 0. Then you go and solve. But the answer will be totally different if you solve it in the very beginning. You get what I mean? Okay? Important this one. Can? Okay, so very important. I think it really goes down to the basics. It's really the basics between the equation and expression. This one I also previously released a content article and an Instagram post for it. Okay. So for all the future questions like that, the last two steps, the plus and minus, are swapped. Okay, I believe you are referring to the CR method for the calculator values and how they came about to here, right? I think that's what you're referring, right? Because it's a bit incomplete here. Are you referring to this one and then coming down to -5 and then this one coming down to here? Is that what you're referring to? Yes, if that's the case, yes. If this is what you're referring, then yes. Why is this so? You see, basically what am I actually doing is that I allowing you to use a calculator to get the final answer if you have solved it. Then you go and reverse it back from here to here. Okay, that means for x to be 5/3, that it must be a linear factor for us to actually get x equal to 5/3 ma. That means ax, oh, what happened to my, okay, what happened, My YouTube stream stopped. Okay, never mind. So basically, there must be a ax plus b equal to 0. That means what happens is that I already got an x value. I'm reversing the x value back to give me my ax plus b equals to 0. You got what I mean? So whatever I say, that means the denominator to the front, then x over there, then x, then change sign, then put a numerator. Is for you to go and actually see for yourself that, hey, today 3x minus 5 equal to 0, 3x equals to 5, x equals to 5 over 3. There are 3 steps for me to get from, there are 2 steps for me to get from the factorized form, the factor, to my answer. There are 2 steps. But what am I doing here is I'm going to reverse it. I do it backwards. This is the powerful part. I do it backwards. Okay, so yes, the signs are always swapped. In this case, do you see that the signs are always swapped? Because in this case, 2x plus 3 equals 0, man. Okay, I do here. You see, when I throw the 3 from my left hand side to right hand side, the signs are swapped. See it? This is how it works. So in a way, your calculator answer actually gives you this one. Then I go and retract 2 steps to go and find my factor. Okay, so this is a very convenient way to do so. Okay, like I said, this is a very advanced but unorthodox method. So for now, while you are learning your multiplication frame, use this method, get your linear factors and put it in your frame. Put it back in your frame, or the cross factorization, whatever the method is. Okay, for coefficients of a that is equals to 1, by all means, you can observe it out already. Using the cross factorization method, by using the multiplication frame, or just by using my observation method for a equals to 1. For any other numbers, don't waste your time. Use this one. Use your CR method. Okay? Because right now there are too many ways to it is too inefficient, and it's not a good use of time. If you were to find a 6x squared minus x plus 15, and then you were to go down there guessing numbers, then you get guess either it's 6, 1 and 3, 2. This is either 1, 15 and 5 and 3, 5. Then you're going to guess which number mixed with which number, then ultimately give me a negative 1. Waste of time. Waste of time. Can I understand? So for a there is more than 1, use CR method. For a equals to 1, go and observe it directly. Can I understand? I tried this method ever since I was in primary school. I was doing Amex. I said primary school because it's like so many years ago. Okay, I did this when how many years ago was that? I did this 14 years ago. Up till today, no one said anything about it. 14 years ago. Up till today, this 14 years, this method still stays. So I'll teach you guys the most fastest and the most efficient method. Okay? Can understand? Yeah. Okay? So if that's the case, maybe you can also throw me another few questions to actually let us have a look. Are there other ways, or are there other questions that we can actually use such a method as well? Okay, there are a couple of questions that I have here, but of course, if you can provide me with your questions, that will be the best. Okay, so that you can learn. I'll just put like 2 questions for us to go and see. Okay, zoom in a bit more. Okay, thanks for the... Oh, interesting. This one. This is a different thing already, by the way. Wait, sorry, 15, like that. Okay, this one, okay, this is not a good place to put it here. Okay, I put it somewhere else, wait. So I'm trying to navigate this thing. Let me just continue to go downwards. Okay, the question that you gave me is very interesting. This is actually slightly different already. They ask you to solve, right? And they say hence. So those of you who are online, if you guys can solve this, go ahead and try it as well. They say hence solve for 6 times y minus 3 whole thing square minus y minus 3 minus 15. Do you see something very interesting? They already bracketed the terms for you. I want you to compare what you have did before, which is here. I want you to compare what you did before and this thing. There are 2 sets of y minus 3. Yes, correct. But on the bigger picture, I want you to look at it as a full picture. Look at what I highlighted. Do you see something is the same? Apart from the y minus 3, obviously y minus 3 is there. Do you see something else that is the same? This is a very important question, guys. What else is the same? I want you to compare among the 2 green shaded equations. No need to push the 15. No need to push the 15 over. Don't push the 15 over. If you push the 15 over, that means you are not seeing the 2 green. You are not comparing the 2. You are not comparing the 2 green lines. I got the 2 green lines for you already. Look at the 2 green lines. What do you see? Super important, this one. For those of you online, this is super important. Okay? Look carefully. Do you see that the coefficients are the same? So imagine if today, do you see it? Do you see it? So imagine if today I take this. Oh, this is so important. Today if I... Oh my bad, this is the green light. 我讲5遍了 please. Okay? Yeah. Okay? So you see if I cover the y minus 3 as a red color part, I cover and I replace x. Do you see it's exactly the same as the other line? It's exactly the same as the other line. It means I take out y minus 3, I put x inside. Do you see it's the first part? Do you see there are actually 2 of the exact same things? Okay, guys, for such questions, if you blindly go and... Oh, this one I got taught before. If you blindly go and expand everything, you are wrong. Especially if they say hence. Because normally this kind of question is either an A, B question. Okay? So does it mean that y minus 3 square minus y minus 3 equals to x? No. It's not that complicated. Do you see that if I take out, as I explain again, listen carefully, if I take out the red parts, which is the y minus 3, and I put back x, wouldn't I get the exact same equation like before? Let's align on this one first. Do you agree that it's going to be the same thing? Okay, So I'm going to erase the highlighted parts. Yeah. Do you see? Yes, 6x squared minus x minus 15. Do you see this? The actually same thing? It's the same thing, isn't it? Okay, I'm going to do is I'm going to just write here and put x. So I get the same thing already. Do you see that I have already solved for 6x squared minus x minus 15 in the previous part? Okay? I'm going to bring the whole top question down again. See ya. This is why we arrived at the previous part. And now, can you see that, like I mentioned earlier, if I take out y minus 3 and put back x, I'll get exact same thing. What does it mean? In this case, y minus 3 equals to x. That means I need to do a replacement here. What am I replacing? I'm going to replace all the x with y minus 3. That's it. Okay? Look carefully. 6 y minus 3 square minus y minus 3 minus 15 equals to 3 y minus 3 minus 5 and 2 y minus 3 plus 3. So I'm just replacing the whole x. I take x out, I put y minus 3 inside. It's the same thing. Okay, so from here, expand as it is. Okay, so I'll get what? 3y minus 9 minus 5, 2y minus 6 plus 3. Then go and solve from there. So I'll get 3y minus 14, 2y minus 3. Okay, so from here, so depending on what the question is, if the question says factorize, this is your answer. If they say equal to 0, okay? Equal to 0 means you continue from here to go and solve for x. But from here easy already, because you already know the factor form already. So in this case, how 3y minus 14 equals 0 lor. So y equals to 14 over 3. Then or 2y minus 3 equals to 0, y equals to 3 over 2. Done. Okay? Don't be too mindful about the answers. Okay? It's not just about the answers, but it's about the problem solving process. How do you see the O shadow? I keep using the same term. How do you see the O shadow in the new form? In the new form where we got 3 times 6 times before, a lot of students, if you guys are not familiar, right, you guys will blindly see, oh, y minus 3 lor, y squared minus 6x plus 9, then you go on and on and on. Then you expand everything, then put together everything, and then arrive at a new quadratic equation, then you go and factorize. That is wrong. Especially when they say hence. If they say hence, means you cannot do that. Because normally when they say hence, right, there must be a previous part. So the key and the technique to do such questions, right, is where you compare the two questions. You compare the two parts. In this case, I got it here already. Compare the two parts. Go and see for yourself, how is it different? So explicitly, I'm talking about here and here. Go and see, how is it different? There must be some similarity somewhere. Then you go and match. It's only a replacement. But it's replacement of what? That is the important thing. Once you see the replacement, right, go back to the final answer of the previous part and take out and put the replacement inside. That's all. Do not go and expand everything one whole crappy long term and then put back inside again. You may get the correct answer at the end of the day. The answer will always be correct. But the method is wrong. If the teachers are anal about it, that's it. You will not get any marks, even if your answer is correct. Important this one. The problem solving process is even more important than the answer itself. So do not do it blindly. I have secondary 4 students up to today, they are still doing the same thing. I still have to tell them, look at the question and compare. Find the old form in the new, find the old shadow in the new form. Find the old shadow in the new form. This is so important. Okay? Okay, other questions? If no questions, then other questions that we are talking about, quadratic over here. This is a very simple application lah, okay? So the second one will always link to the first one. 95% yes, 95%. 5% they tell you hence or otherwise. 5%. But most likely yes. Good question. It's always, I would say 95%, really 95%. And normally when they string it together, the first part will be always a 3-mark question. For you to do a factor, right? Maybe a 2 to 3 mark question. So whenever there's a hence, it will be related to part A. Yes, good question. You're right. Okay, this one a bit of exam techniques. I'll talk a bit of exam techniques. Good point brought up. If exam techniques how do we determine whether the answers are the parts of the question, right, is related or not? This one is a bonus. It's a bonus. Exam techniques. Normally, right, they give you 1, 2, 3 Okay? If the questions give you A and B, if the question give you A and B, right, then here they say hence. If they say hence, it must be related. Must relate. If the A and B don't say anything, just A and B, maybe not. Okay? However, why do I really talk about this one? Because you say either or possible so A and B no link, right? No. There are actually 2 ways. The questions are actually very tricky about this. The way they set the questions the way they name the questions is actually a clue. Okay? So for A and B, if hence, right, it must relate. If A and B are just there, it may be not. If sometimes, right, what happens is that they question 1, then you got 1A, 1B. It just means, sometimes it may just mean, right, this question itself, right, whether it's A and B, right, test you on the same topic. Same topic of chapter. But the questions and the answers may not relate, by just asking you on the same chapter. So maybe, for example, a very common one, areas and skills. So A and B may ask you different things. However, if they have another type of question which is I and II. If it's I and II, according to my years of experience, like, they will relate. There's a difference. One is AB, one is I and II. Very interesting one. If it's I and II, more than 3/4 of a chance that it will relate. Okay, so use the question, how the questions are being numbered actually gives you a small clue. So a very typical part 1, so this is called A and B question. This is a part 1, part 2 question. Okay? So a normal part 1, part 2 question, right, will be where they give you an equation, ask you to form an expression of x. Then use an expression of another x. Then put them together and show that the equation links to something equals 0. Then solve for the equation. Then use the final x value to go and maybe solve a certain number or value, or maybe reject one of the values. So in this case, right, there will be 4 parts. So it's I, IV. 很少会出 A B C D 的 It's very rarely they will give A B C D for that. Okay, so always take note in terms of how they number their questions. Very important. Okay, naming, this is naming convention. This one quite cool. Lucky we managed to bring up about this one. The A, B and the I. Okay, can So with that, okay, he got another question on this one on okay. Okay. They gave me this question. Okay, I try to draw it out. Okay, a rectangular field 70 meters long and 50 meters wide is surrounded by a concrete path of uniform width. Given that the area of the path is 1024 meters squared, find the width of the path. I believe for such questions, there will be a diagram given to you. But since you cannot give me the diagram here, I try my best to recreate it. You let me know whether it's correct or not. My impression of such questions should be like that. So the path is here that walks one big round. Okay? No diagram. Interesting. Too bad lor. 70 meters long, 50 meters wide. I think it should be like this. My impression and my experience tells me it's like that. Okay? So they are telling me that given the area is 1024 meters square, find the width of the path. They say that it's of uniform width. 这个没有很难啊。Okay? 没有很难啊。Look the whole thing is okay. Since they tell me it's uniform width, are there certain variables that we can set? Look carefully. Let the width be x. Can? Even though it's quite obvious, because anyway it's just one round like that. But annotating this right will help me to see what I'm doing later. Okay, wait. The 70 and 50 is supposed to be the inner rectangle, right? I doubt so. If the I think this student is slightly confused because there is no diagram that is being provided. Whether right now the concrete path is being on the outside of the field or whether on the inside along the perimeter. According to my experience, it should be on the inside. But however, like I said, benefit of doubt. Can it be outside also? Very possible. In this case, can we actually solve for both scenarios? Let's solve for both scenarios. And then for this student over here, let's go ahead and do 2 scenarios and make sure it works. How about that? Okay? It is said to surrounded, so should be outside. Okay? So according to his interpretation, let's go ahead with that. Because either way, I can solve the problem. It doesn't matter. Okay, we must learn how to go win-win lah. We don't go either or lah. Let's go for both. Okay? If that's the case, let's go with this. Shall we? Let's find out a bit more about this one. This is actually quite a very good algebra exercise. I'll just leave it over here first. Okay, so once again, we have our x. So I say let the width be x cm. Pretty easy for this one. So can we actually find the area of the inside first? Let's find the area of the inside first. Okay, so the area of field should be 70 times 50. This one pretty easy lah. 3,500 meters square. Very easy. So now they say that the area of the path is 1024. So if let's say they, like what we have discussed, the field is actually the inner triangle, right? Inner triangle. So can we find the outside triangle then? That means the field including the path. I want to find the total area. Can I find that? We can, right? No. Yeah. Oh, this is meter, right? Sorry. Meter square. X meter. So it should be X meter. So 3,500 meter square plus 1024 meter square. That should give me 4,524 meter square. Okay? And then from here, how do we continue? Do you see that we are able to establish the new length and the new breadth given the 70 and x? Okay? So from here, can I say that 4,524 is equals to the length? What is the length? 70. But it's not just 70, oh. It's 70 plus 2x because I'm looking at 70 plus x plus x. The other one will be 50 plus 2x. From here, it's very easy. Expand, quadratic, solve. Can do? Can solve already? So from here, 3,500. I want you to go and try yourself also. Try it yourself as well. Okay? So before I really go into the answer, I want to really consider the other scenario. I'm going to draw the same thing again. Where the path is inside. Okay, my figure sucks lah, but yeah, you get my point. This scenario 1, this scenario 2, I want to really establish the point and the fact that it's not the solution that I'm looking for. It's the problem solving process I want to guide more instead. So same thing, I want to let my uniform width be x. So let width be x meters. So same thing. Can I do the other way as well? I can, right? So the field in this case will be 70 times 50, 3,500 meters square. So in this case, it will be 3,500 minus 1,024. That will be 2,476 meters square. Can this work as well? Why not? So in this case, how would the equation differ? 70 minus 2x, 50 minus 2x will be equal to 2,476 meters square. From here, go and solve. So I've presented two cases over here. Now because after that it will be very easy. Ultimately, we are looking at what is the context, what is the instruction of questions. But either case, I got my equations out there. So which one you're looking for, you plug in. Now I want to go back to the question again. Surrounded by a concrete path. I feel that the first case might be more correct in this case. Surrounded. Oh, this is quite ambiguous. Quite ambiguous. But nevertheless, let's solve for both. Shall we solve for both? Okay, if that's the case, if we are more inclined to the first solution, I will solve for the second one. So you guys can use the process and go and solve for the first one. You think I so nice why I give you the answer, right? No way. Okay, you'll go and solve for the answer yourself. I'm going to try the other one, which is the supposition that I did, the assumption that I did. You think I'm going to give you the answer, right? No. I give you the other one. Go and solve it yourself. Haha. Okay, let's take a look here. Okay, so if I expand it from here, oh no, it's not my height. So it'll be 3,005, then minus 140x minus 30x plus 4x squared equals to 2,476. So 4x squared minus 170x minus plus 3,500 minus 2,476 will be equal to 0. So from here, straight away use the calculator. Don't deliberate too much. 这种不用想太多的。Okay, so it will be equals to 1024. Okay, straight away take out a calculator, give you your answer. Okay, don't bother for such numbers that is going to thousands. Don't bother using the observation, cross factorizing, multiplication table. Forget about it. Use your calculator. Okay, we got no time for that, man. Okay. So in this case, I key my calculator. I check that my answer is either 35.23. So it's 3 sig fig should be 35.2 meters to 3 sig fig, or the other one will be x equals to 7.2656, so approximately 7.27 meters to 3 sig fig. That will be the answer if my supposition will be correct. But on the other case, let's go back to here. Matthew, have you solved it? Have you solved for it already? Should be quite easy from here already. Can do not? Can do not? Okay, in any case, let me quickly solve it on my own, and let's see if you can get the correct answer. Okay. Oh wait. Never mind. You continue your first solution first. I got careless error here. This is not 30. This is actually 100. So this will be 240. 140 100 240. Okay. Okay, so I'll get another set of answers over here. So this is a 240x. I'll get 55.37, so 55.4, or 4.6228, so 4.62. Okay, coming back here, have you solved it? No? Where are you at? Shouldn't take you very long. Okay, so the manipulation shouldn't take very long for here. I didn't understand your one either. So, what is it that you don't understand? You must ask. Your concept of having it on the concrete part on the outside is correct. Concrete part on the outside is correct. Okay, because I got a whole number already. Is that 140x? Yes. Hey, don't look at my answer lah. You go and solve yourself lah. Multiply term by term. 70 times 50, 70 times 2, 2 times 50, 2 times 2. Is it 140x? Yes, 140x. I already done my answer. Yes, you will get a whole number. Hello, term by term. This should be a pretty easy one. Okay. I will leave the answer. I will leave it here for you to continue to solve. There is one number. There is indeed a whole number answer. Okay, just to give you a clue, it's a whole number. There is no fraction, no decimal, no nothing. Okay, let's see if you are able to arrive at the answer. Okay. Okay, for those of you who are online, you guys can go ahead and try it out as well. The most of the methods are already on the screen itself. Okay, so basically case 1 is correct. That means the path is on the outside lah. The path is on the outside. Okay, fair enough. But not difficult lah. If you were to draw a diagram, like over here, if you were to draw a diagram and to suppose, because we have learned about x already, this is the basics of x. That means you let x with something, then you go and solve, then you will get it already. Okay? Okay, so for those of you who managed to get the answer already, let me know if you managed to get the correct answer. Wait. What you are getting is wrong, by the way. How did you even get 244 in the first place, my friend? Hey, this one is the basics of term by term, so do take note, all these powers and stuff are like the most basic stuff, the most basic techniques and things to look out for. So yeah, do take note as well. Okay. Okay, so ultimately, I shall not hold up too long about this one. So ultimately, you will get a very nice quadratic equation with very nice answers. But of course, there will be two values. There will be one value that is positive. There will be one value that is negative. So just need to take note that in this case, you need to go and reject this thing. Because why? We always need to relate back to the context of the question. Okay, quite important on this one. If the question says solve for this equation only, you do not reject anything because there's no context. However, if this quadratic equation appears in a long question, maybe a story based, in this case it's a story based, they tell us that area of the path, width of the field, things like that. If this equation is being inbuilt in the part of story, right, we need to go back and see the context and whether every answer that we got makes sense. If the answer that we get and we put it into the story and it don't make sense, we must reject it. So this one relates a bit of a context. Needs a bit of context. So in this case, we need to reject the negative answer. And why is that so? Because just now, remember, how do we define our x? Our x is being defined as the width of the path. If you are talking about width of the path, how can the width of path be negative? It cannot be negative, man. So therefore, we must always, in this case, in this context, we reject the negative answer. Okay, so this is just a small reminder for those of you who are still solving for you solving the questions. Okay. Okay. There are some guys who want to come in. Sure. Yeah, let me see my. Do you manage to get the answer? Do you manage to get the answer? Oh my god, did you just ignore me? I got minus 25 and 35 and redoing. Okay, so I'll just leave it to you to go and do the questions on your own. I think these are very good questions for us to actually practice on such algebra questions. Okay. Anyway, since you already got the main equation already, so I'll just leave it to you. Okay. Any other questions? Any other questions that you want me to run through? Can I use the CR method for the main equation? Yes, of course, you're supposed to. But only after you get all the coefficients aligned properly lah. That means you have a distinct value of A, your B, your C. Then you put it in the calculator. Yes, you're supposed to. You're supposed to. Okay? You're supposed to. There will always be people that is asking me, the same thing again and again in my group chat, which is 4240 and 3500. Wrong wrong You forgot this thing in front not careful enough. Remember, to key it in the equation, right, you must always equate to 0 first, then you key in the equation. Okay, so I believe what you get is 4x squared plus 240x plus 3.5k. Correct. But on the other side of the equation is there's a 4524 there. So you need to do something about it also to make sure that the whole equation equals to 0. Then you can put it as your calculator. Okay? Quite important, nice one. Okay, can ah? Can ah? Ah, very good. You got your answer already. If you got your answer, then I can go on already. Yay, finally. Okay, so ultimately you'll get 4x squared plus 240x plus 3. Is it whatever I have here, lah, basically? Yeah, I already waiting for you already. What are you waiting for? Okay, for this one, your constant, which is 4x squared plus 240x minus 1024 will be equal to 0. Your x will be equal to 4 or negative 64. In this case, this negative answer must be rejected because we are talking about the width of the path. Or width of a path cannot be negative value lah. So it will be for the positive value. Okay? Okay? Can. Any other questions you get? Okay, like I said, for those of you who are online, so I'll be doing such of a guidance to specific questions that students may ask when they come into Zoom. Okay. Otherwise, I will just continue on general topics that I will pick along the way. Okay. Okay, just now before we went into the algebra questions, we were talking about this area on the combinatorics. So it will just be along the way lah. Come, any other questions that you want me to go through? If not, then I'll just go back to my Pascal triangles and my n choose r already. so far not yet ah. So far not yet. Okay, can. Okay, if that's the case, then I will just leave you as here. You can stay on the Zoom meeting to listen further. When you got questions, then you just ping me. Okay? Can. If that's the case, then I'll just go back to my Pascal triangles and combinatorics. Okay, where was I? I think I lost myself in the whole of my n choose r is on top. Okay, let's just go a bit there. Go a bit there. Here. Okay. Okay, so back to the n choose r thing. Sorry for little delay. Like I said, this is how I plan to do my quickfire. Whenever there are questions coming in, I will entertain those questions. Otherwise, I'll be just going through topics. Or certain topics that I want to go through lah. Okay. Okay, recap a bit. So just now we will have like the Pascal triangles, the using calculator values, and using about n choose r. So basically, how we recap that n choose r means using the number of possibilities for r number of objects given n objects. That means 5 choose 2 means how many ways you can choose 2 objects out of 5. 5 choose 2. That means in short, there are 10 ways. That's how we look at it. Okay? So for this n choose r, and just now where we left off is that how do we find out these values without looking at a calculator, or in a way a more manual way to do so. Okay? So we're going to talk about this thing called factorial. Okay? Factorial. So the factorial is this exclamation mark over there. So for example, when I say 5 factorial, it's not 5 with an exclamation saying to it. Okay? It's not 5. It means it is a product of 5 times 4 times 3 times 2 times 1. When I say 4 factorial, it means 4 times 3 times 2 times 1. That means all the way from that number all the way down is a multiplier of all the numbers. So in this case, 5 factorial will be 120. 4 factorial will be 24. Okay, so one thing very interesting to take note is that if I were to go lower and lower, look carefully. This is 6, right? So 2 factorial means 2 times 1, which is 2. 1 factorial it's 1. Now, here's the interesting part. How about 0 factorial? Interesting, right? There's nothing to do. There's nothing to divide. Okay? How? So does 0 factorial equals to 0? Infinity? No answer? Error? What is it? Okay? So in fact, 0 factorial is equals to 1. 0 factorial is also 1. Then say, why? 1 factorial also 1 ma? 0 factorial also 1 ma? So why is it 1? Share with you guys an idea. You see, from 120 to 24, we divided by 5. From 24 to 6, we divided by 4. For 6 to 2, we divided by 3. From 2 to 1, I divided by 2. Therefore, from 1 to 1, I divided by 1, which is 1. Interesting, a lot of people understand that, 1 factorial is 1, 0 factorial, then they kind of blur that 0 factorial, what's the value of that? Okay, 0 factorial is just 1, based on this idea. Okay, this one, just a very short snippet, just for you to find out more. Of course, there can be, since it is also existent for all positive numbers, that means it can go infinitely lah, but it's a bit meaningless to go find so big numbers yet. However, once we understand factorial, we can understand what is the general term for n choose r. Okay? So when we say n choose r, what does it mean? It means n factorial divided by r factorial times n minus r factorial. Then say, what is this thing? So long. How to remember? No choice, have to remember. Okay? This one, I have to say this is one of the most weird thing that we have to remember, because it's just that way that we need to find it. Okay? Okay, let me try to find a way. Let me go and find the equation to show you guys. Okay, so far there's no r factorial. For r factorial is under another level called p. So it's just like that. Okay. Just like that. N factorial minus n minus r factorial. So in this case, just now I have like 5, 2, right? Because I say 5 choose 2 ma. So in this case, the example, how will we apply it here? It will be 5 factorial over 5 minus 2 factorial, which is equals to 5 factorial over 3 factorial. Order matters. Order matters. Sorry, just now I got myself mixed up a bit more. So it's just got the R lah, got R. Because when order matters is a different thing called permutations. But since you are only looking for combinations, which is where the order doesn't matter, we need to do a R factorial as well. Combinations. Yes, correct. N factorial over R factorial minus N minus R factorial. Okay, so coming back here, so we have a 2 factorial like this. So it's 5 factorial divided by 2 factorial times 3 factorial. Just like that. Okay, so if we to plug in the numbers according to what we had learned earlier, so it will be 120, which is 5 factorial. 2 factorial is 2 times 1, which is 2. 3 factorial is 3 times 2. 3 times 2 is 6. This is how we get 10. Okay? So there will be instances where they give you a certain value, and then they ask you to go and find n or find unknown values, given the fact that you know this formula. Okay? Yeah. Okay, so this is the way to do it. Let's use another example. Okay, so for example, I have 4 choose 2. Using the same formula, can I do it? 4 factorial divided by 2 factorial and then 4 minus 2 factorial. Okay, so that will be 4 times 3 times 2 times 1. That will be 24. 24 over 2 factorial, which is 2, and then another 2 factorial, which is 2. In this case, will be 24 divided by 4, that gives me 6. So 4 choose 2 is 6. And in the longer term, in terms of definition, what does it mean? That means if I have 4 items, out of the 4 items, how many ways I want to choose 2 items? There will be 6 ways to do. There will be 6 ways to do this arrangement. Okay? So 4 choose 2, something like that. Okay? Okay, previously I came across a question where we are supposed to go and find a release value. We are supposed to find the unknown values that means they give you the final number and then they ask you to find n. Okay, quite interesting. Okay, this one allows us to actually have a more solid understanding about how this n choose r the definition works. Okay, let me show you guys this question. It's very tricky, just like that. Just like that. N choose 2 is 28. Then you get, huh? Find n. Yes, I saw such a question before. And this itself, this factorial question itself, is 3 marks. It's 3 marks. Quite anal, but have to. Okay, so let's go back and see the formula. So basically, n factorial over 2 factorial over n minus 2 factorial. Okay, of course n minus 2, this 2 factorial that we see is quite obvious because you know that 2 factorial means 2 times 1, which is 2. Okay, so let's write it again. So n factorial over 2 times n minus 2 factorial equals to 28. Okay, now before we go into solving and understanding the factorials and how it changes and stuff like that, I want to clean up my expression such that it is very convenient for me to solve. So I want to bring the 2 over. Okay, so n factorial over n minus 2 factorial equals to 28 times 2, 56. This is what we know so far. Okay, this is what we know so far. However, now we got this little thing over here. N factorial over n minus 2 factorial. How? Have you ever came across your mind? How? Give you an idea. Okay, this one, right, even though it looks very complicated, because it's just n factorial and all that stuff, right? But if we were to break it down, right, it's actually very simple. Let me show you guys an idea. Remember when we talk about n factorial? N factorial, what does it mean? N factorial means that if I were to, that means the number will go down all the way to reach 1. That means n, then n minus 1, then n minus 2, then until 1. Then all the numbers you multiply together. So imagine if I will expand n factorial, it means it's n, okay, so it's no longer factorial, So it will be n times n minus 1 times n minus 2 times n minus 3 times to 1. That is the meaning of n factorial. Regardless of what the n is, n can be any value, but you get the form. It's just the idea that we're looking at. This is the whole numerator thing. Now, n minus 2 factorial. What is that? That means the number instead of n is n minus 2 lor. Okay? So we start for n minus 2. n minus 2. So what is 1 below n minus 2? n minus 3. n minus 4. Okay, so I'm just going to put it here. n minus 4. Then times times 2 times 1. Do you see something very interesting over here? Do you see that this part, the whole of the denominator is actually equals to here? It's the same thing. This is the powerful part. Therefore, what can be done? This whole thing can be struck off. Therefore, what is the what is the expression if I were to simplify things? What is the expression of n factorial divided by n minus 2 factorial? It will be n times n minus 1. Okay? So from here, it's super easy to solve already. So n times n minus 1 equals to 56. So that means the n must be 8. This is how you solve for n, the value of n in terms of n choose r. Okay? Quite interesting for this kind of questions. But it's quite rare that we get these kind of questions. But however, there will be certain cases where there will be certain cases that such questions will be asked. I know this is a sub-branch from combinatorics, but in fact, this itself is combinatorics. Okay? So, of course, this is just an additional question that may be tested based on your knowledge on n choose r. Okay, but the binomial theorem is the main part, but this one we have to go into this one first. Binomial theorem itself is really a lot of things to say. Okay? Okay, so now that we're done with the n choose r thing, let's come back here. Okay, you got 5 choose 2, 4 choose 2, we can learn about factorials, we can learn about finding value of n, things like that. Okay, now we have understood the n choose r. Let's go back to the general term. Remember the general term? Which is over here. Okay, let me erase this one first. Okay, done. So this is the n choose r that I'm talking about. Of course, you know how to find the values through the calculator. In the calculator, right, at your number keys, right, there should be a value, there should be a second function or NCR, NPR. Okay, there's a NCR, there's an NPR. So in this case, we are talking about NCR. CR means choose R. PR means permute R. That's a different thing. Slightly more complicated, but the core concept is there. Okay, can? So basically, n choose R, and then we got all these powers looking thing. How does it work? Okay, so in this case, imagine if today I want to find the 8th term. Okay, for example, they say the 8th term. 第八个 term, 8th term. Okay, so when we say the R plus 1 term is equals to n choose R, A, n minus R, BR. Why R plus 1 term though? You must be asking. Why not R term? Why not R term? Okay, in fact, the most interesting thing is that, you see, because n choose R in our top, you see our top 3 terms over here, it starts with what? It starts with 0. Okay, that means what? The first term is when n choose 0. And n choose 0 is what? How many ways for us to choose 0 items out of n items? Okay, n choose 0 is always 1. Okay, so so this one I have to go back a bit to the n choose R part. Okay, a few properties I have to learn. I think it's easy, it's for us to know, but if you want to deduce it, it actually can be done as well. So you see, if I say n choose 0, it means how many ways can I choose 0 items with n items given? 1. I don't choose anything. That's the only one way. I don't choose anything. Means n choose 0. Okay? N choose 1 means what? Out of n items, how many items can I choose 1? How many ways can I choose 1 item? Means there are n ways, no? Because every item I choose 1. N items, that's it. Okay? Now, the value of n may go extensively all the way to don't know how many numbers. But however, there must be a way that someday that n will be, or where the value of r is only one less than the value of n itself, and it will still be n. No, n, sorry. 1. Why? N choose 0. No, it's n. Am I confusing myself? N, yeah, n. Okay, so you see that n choose 1 and n choose n minus 1 is actually the same thing. If we think about it, we go back to n choose 1. N choose 1 means that how many items can I choose? How many ways can I choose one item out of n items? On the other hand, I can also think of it the other way. How many ways can I not choose n items? And how many ways can I not choose one item out of so many items? That means I take everything else, leaving that one alone. It's the same thing, because let's talk about leaving it alone. So in this case, I can say, when I say n choose n minus 1, means I take everything else except 1. Okay? So basically what it means is that how many ways can I exclude one item? There are only n ways to do it. Therefore, n choose 1 is the same as n choose 1. N choose n minus 1. Okay? And likewise, back to the ultimate, how many ways can I choose n items given n items? 1. Take everything lah, 包括了. Everything 打包 means 1. There's only one way for me to take everything, which is to take everything. So n choose n, also 1. Important. It won't test you on this, but we must know that this is a property lah. It's a property. Okay? So back to the n choose r thing. I mentioned that the first 3 terms is n choose 0, n choose 1, n choose 2. Okay? So the first term is always n choose 0. So do you see that for the first term, the value of r is always 1 lesser. So for second term, you see for here, so you can see that for the second term, let's focus our attention on the second term. So for the second term, right, my value of r is 1. For my first term, my value is 0. So when the value of r is r, I'm referring to the r plus 1 term. That means if my r is 7, I'm looking for the 8th term. If my r is 8, I'm looking for the 9th term. Can I understand this one? Okay? Important this one. So sometimes they will ask you, they will give you an expression, they say find the something term, find the 17th term or the 6th term, whatever. Okay? So shall we just quickly use an example to actually help us find the value? Okay, we can. Let's go ahead and find it. Okay, now it's finding the n term. Or now we know that n plus 1 is finding the r plus 1 term. Okay, so right now it's about 19:25, so we can we got another half an hour more. Okay, interesting is that the people in my WhatsApp groups are actually more active in the evening. So I just received a couple of DMs over there. So we shall see if they are going to put in questions. They always put in questions last minute, but I try my best. Okay. Every week there will be some late people telling me that, oh, you're a teacher, huh? You're a teacher, huh? You're a teacher, huh? Where every week I've been talking about the same thing. Then they will always forget. Okay? Whatever. Doesn't matter. Okay? So back here. Finding the r plus 1 term. Okay? Maybe I zoom this out and then maybe I drift it down to the bottom. Okay, there's a more space over here. Okay, I'm going to use the same formula here. So n choose r, no. So I say a plus b n is equals to, okay, general term, not a plus b n. Okay, n choose r, so a, so yeah, lift it down a bit, n minus r, br. Okay, and one more thing to take note is that always ensure that the powers for the two terms, right, always add up to n. That makes more sense because one goes up, one goes down, man. So the powers must always be equal to n. That's most important. Okay, so let's have example over here. So for example, I say a plus b to the power of 6. Find the third term. Okay, so when they say find the third term, what's my r? Okay, remember r plus one term, so r plus 1 is 3. Okay, therefore r is 2. Correct, 2. Now I'm going to bring this r back inside. So this n is this power. This is my n. So the third term is equals to 6 choose 2, and then my first term, which is a, so this is n minus r. N minus r is 4, and then my b is going to be 2. Okay, but I cannot leave it like that because we know that this 6 choose 2 can be evaluated to be a value, in which what we call a binomial coefficient. So this binomial coefficient, it is an exact value, it's an integer in fact. So we must use the calculator and go and find the value for 6 choose 2. So I key into my calculator and the answer is 15. So my answer will be 15a to the power of 4 b squared. This will be my third term. Okay, so I haven't moved into the notion of x and integers and stuff. I'm still using a and b. This is for you to understand on the general term only, just on general term. To know how the powers actually work and finding the r term. Finding the r plus 1 term. Okay, I will use r plus 1 term, easier to remember. Okay, so for example, I want to go, can I go bigger? Can, of course. R plus b to the power of 7. So I want to say find the fifth term. Okay, works the same way. So r plus 1 is 5. So r is 4. So I'm going to plug in over here, same thing. So my fifth term is equals to 7 choose 4. Then is a, this is 3, then b, 4. This will be my fifth term. So of course I need to go and calculate again what is 7 choose 4. 7. So 7 choose 4 will be 35. A cubed b to the power 4. Okay, so now we understand the finding of the term and we managed to observe how it changes with the power. Now let's put in the x, the real thing, the x. Okay, so using the same idea as above, today I have 2x plus 5. Okay, then I have, okay, don't terrorize your bit, x plus 5. Okay, x plus 5. Okay, x plus 5 to the power of 6. Power 6, high enough, right? I say find the third term. Okay, so same thing. R plus 1 is 3. So r equals to 2. So therefore, the third term will be equals to, remember, I do not need to go and expand one by one and then get a third term. I use the general term to give me my third term immediately. Okay? So I use my third term, which is 6 choose 2. Then is x. That means whatever is on the first term. Whether is it x, 2x, x squared, whatever. Put it in. Okay? Put it in. Don't be confused subsequently because now it's x. It's very simple. You see 2x, you see 2x squared, you see whatever, blah, 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 blah. Don't care. Don't care. Put inside. Don't care. Just put inside. Okay? Put the whole thing inside. Don't just take out the x and throw everything out. Put everything inside. So x and then COE will be n minus r. N minus r is 4. Then 5. Then you got a 5 at the back, right? You got a 5 at the back. Then it will be, what number would that be? What number would that be? 5 to the power of 2. Correct. Okay? Then from here, let's continue. Because 6 choose 2, I need to go and find 6 choose 2, I learn is 15. Then this is x to the power of 4. But the back value, I can evaluate all. So it's 25. So I need to do a 25 multiplied by 15. Oh wait, hang on, what's going on? I can only do a, oh wait. 25 times 15. So in this case it will be 375x to the power of 4. This will be my what term? Third term. Okay? So whenever it's x, 2x, 2x squared, whatever, same. Okay? Then in some other cases, they will say find the coefficient of the third term. In this case, we are using a third term, using the same example. X plus 5 whole thing times x plus 5, the whole thing, holding the power of 6. Let's say they say find the third term. They say find the coefficient. Okay? Now there's a new word. Find the of the third term. So in this case, I found out the third term to be 375x to the power of 4. So what's the coefficient? The number in front, 375. That will be your answer. So always watch out for what the question is asking. Sometimes they ask you the term. Sometimes they ask you the coefficient of the term. Sometimes they ask you for the constant. Constant is what? What is constant? If they ask for constant, means it is called independent of x. That means in that term, there is no x. No x, just a number. Okay, like for example, in this case, is there a chance where this question could actually give me a constant? Yes, because ultimately, if I expand everything, it will be 5 to the power of 6. Right? I don't care what's happening in the middle. Whatever, 375x4 15x whatever, don't care. But I know that the last term will always be constant because it's always 5 to the power of 6, which is 15625. So if they ask me for a constant, they say, okay, find the term independent of x. 15625 will be your answer. Okay? Constant, independent of x, that's what it means. Okay? So this is more on finding the third term, finding the individual term, and finding the coefficient. Okay, I know the way and the sequence in which I taught this is slightly different because in schools you guys have been taught how to expand a couple of terms first few terms. first 3 terms. It's just using this method lah. Okay, so we'll come to that right now. After we understood how the general term works already, because it's the first term, the second term, the third term, so on and so forth, I can use that idea to replicate for the first number of terms I can looking for. Okay, let's continue. Okay, moving on. Now we are talking about things like expanding. Expand something and expand the first, for example, first 4 terms of something, then to the power, maybe I just use the 2x plus 5 lah, okay, or 2x plus 3 to the power of 7. Okay, in ascending, okay, descending, sorry. Descending powers of x. Okay, you see, I just now make a correction. I change ascending to descending. Why? Okay, quite important this one. When is in this kind of question, expand the first 4 terms in this expansion, or in descending powers of x. There are a few things that we need to, some keywords that we need to take note in this question. Number one, obviously we need to know how many terms we are looking for. If you give them extra, wrong. There are this anal about it. Secondly, ascending or descending powers of x. Why is this so? Because take a look. Just now when we talk about the expansion of the first few terms, is the n choose r thing. Remember the n choose r thing? Okay, I want to quickly bring you guys back to, where is it? N choose r, no, not this one. No, not this one. This purple color one. Okay, back to the general term. Do you see what happens for here? When I have the a plus bn over here, my first term, the power of the first term, is go up or go down? It goes down because it starts from n to n minus 1, and then you go on and on and on to 0. So the power of the first term goes down. On the other hand, the other term will go up. 0, 1, 2, 3, to n. So you see, one go up, one go down. Always remember, the first term, the power go down. The second term, the power go up. So that means, back to where we were asking just now, where we wanted to look for the first 4 terms in descending powers of x. Okay, I'll just quickly navigate to there. Of course, in the school, they will ask you to learn ascending powers of x first, but they very happily put the x at the back. They make things easier for you. Okay? In this case, most of the time, it's not the case. Okay? Back to this idea, the powers go down and the second one goes up. So when I say descending powers of x, I want my x to start from the highest number and then go down. So in this case, I need to make sure my position of the terms is correct. It should be 2x plus 3 to the power of 7, not 3 plus 2x to the power of 7. This will be wrong. You see now the order matters. The order actually matters. Because in this case, you will get ascending powers of x. The 3 to the power of something will go down, because the first term goes down, the second term goes up. But that's not what I want. My question is descending powers of x. So descending powers of x means I need to put my x at the front. The front. Very important. Okay, so this is not what I'm looking for. So first 4 terms let's start. Okay, Same thing, using my general term idea. First term means my 7 choose 0, 2x to the power of 7, 3, 0. I know a couple of things can be struck off, but I want to leave it here for standardizing. Okay, so that we are not confused on what to do. Okay, this is the first term. Then I continue. Okay, second term. So this 2x, the power will go down by 1, where the 3 will start to emerge. You see? Okay, this second term. Okay, a lot of writing involved, but you see that the things I'm writing are very straightforward because we already got all the materials already. So we just need to put it in. So this is the third term. And then lastly, I'm going to put for one more. 7 choose 3. Then 2x 4. 3 cube. But you see that you will notice, right? I do not need to really go and memorize what's the general term, I just need to do it for the first one. Right? Then you see all the powers, right, will just change accordingly. 7, 6, 5, 4. Then the other side, my powers will just increase by itself. 0, 1, 2, then 3. Then the n choose r will be 1, 0, 1, 2, 3 respectively. So 就可以了. That's all. Okay? So I just need to know one. I can do the rest of all. Okay? At the same time, there is something that I need to add in. Is this thing called the plus dot, dot, dot. Because we are being asked for the first 4 terms, that does not mean that the other few terms, right, don't exist. It exists. It's just that I only want to know the exact value for the first 4 terms. The rest, I don't care. I leave it as dot, 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 dot. Okay? So I need to go and evaluate for the individual values here. So in this case, 2 to the power of 7 is how many? I don't know. 128. Should be 128. Okay? So 7 choose 0 is 1. So this is 1, strike off. 3 to the power of 0, 1, strike off. So it's 128 power of 7. Then I continue. This is 7. I don't rush to get the whole binomial coefficient out or the coefficient immediately. I leave it in the bracket so that I will be very clear what I'm doing. Okay, so 2x to the power of 6 is 64. So it's 64x 6. Then this is 3. Then continue. Just continue the pattern. So this is 21. This is 32x 5 9 plus. Okay, continue. So I'm also doing 7 choose 3, which is 35. Then 16x 4 9 plus dot, dot, dot. Okay, so in this case I do not need to I do not need to rush to go and put all numbers together. I leave it like that, very clear, very neat. Then I use another step to go and multiply all the numbers together. Okay, so I got 128x to the power of 7. I got 21 times 64, which is 1344x to the power of 6 plus 21 times 32 times 9, which is 6048 x to the power of 5 plus 35 times 16 times 9, which is 5040 x to the power of 4. Then I'll go on like this. Because the rest is don't need I don't have the value plus dot, dot, dot. Okay? So this will be my answer. As you can see, the numbers can go very, very, very big. 5,000 plus. 5,000 is considered small. There are 5 digit answers before. Like just now we did 5 to the power of 6. 15,625. It happens. Okay? So from here, basically, have I found out what I'm looking for? Yes. We got the first 4 terms. 1, 2, 3, 4. We got the first 4 terms. And let's check. Is it in descending powers of x? Yes, it is. So because it's x to the power of 7, x to the power of 6, x to the power of 5, and x to the power of 4. So this will be my answer. Okay, so this will be what is it for the expansion of binomial. Okay, so normally they will ask you to expand the first n terms or first number of terms, then they give you an expression, you can do it yourself. So basically when you're asked for such questions, all you need is just to use this format and then to plug in the numbers bit by bit. Okay, like I said, do not rush. You see, I did another one more step to ensure that I'm multiplying the correct numbers. I do not need to rush and key in the calculator and then solve for everything. Don't do that. I'd rather you spend a bit more time, write out everything neatly, and then you go and solve for it as it is. So don't rush. Okay, but however, it's more of there's no need for you to rush at all. Because once you rush, you get the numbers wrong, then it's a bit no point. I would say it's no point to do it. And it's quite wasted if you get these kind of things wrong. Okay, so this is for the first 4 terms. Okay, and it's on descending powers of x. If they ask descending, if they change the question around, they say ascending powers of x. Can I do it? Yes, of course. It's the same thing. Okay, so for example, and then using this example, I'm going to show you a special case. A special case. First 5 terms, ascending powers of x. Okay, so once again, the question comes already. We must check, number 1, how many terms we are looking for. That's number 1. Number 2, ascending powers of x. So since it's ascending power of x, I want my x to be at the back. So the front is the one that's descending, the one at the back is ascending. So this is in the correct order. Very good, we are good to go. So let's go ahead and to start the expansion, we write down the original equation. Then we start. 9 choose 0. You see, very interesting is that the first term, the constant is a 1. But we don't put it as a special case first. I want you guys to see the special case at the back. Okay, I would say it's more of a coincidental thing as compared to a special case that you need to remember separately. Okay, so let's continue. Let's put the 1 inside. 9 x 0. This is the first term. So 9 choose 1 to the power 8 x, then 9 choose 2 1 7 x squared. 1 2 3, 2 more terms. So 9 choose 3 1 to the power 9 8 7 6. You see, I'm just counting only. So 0 1 2 3. Okay, and one more term with 9 choose 4 will be 1 to the power of 5 and then x to the power of 4. So you see in this case, what's something very interesting? Because the first term is a 1. Because that means 1 to the power of anything, it's a 1. Alright, so in fact, the number itself is the coefficient itself is the binomial coefficient. It is the binomial coefficient already. So we just need to use it as it is. So the first one will be 1 to the power of 9, which is 9. Okay, then this is also 9, but it's 9x. Then 9 choose 2. I need to go and find already. 9 choose 2, 36. Then 9 choose 3, 84. Plus 9 choose 4, 126. Okay, so in this case, the coefficients of the expression is exactly the binomial coefficient. So there's no additional numbers to multiply. As compared to the first equation that we need to do like multiply by 2, then there's a 5 at the back, you need to multiply the 5 square, 5 cube and things like that. So there's nothing of those here. So in this case, this becomes a special case. A special case when the when the binomial coefficient is the coefficient itself. That's all. But however, this only happens when the constant is 1. Other than that, the rest is like you just get to go back to the general term or general expansion way itself. So I don't really like to talk about the special case. I just like to take it as a general case, and this is just a friendlier version of the expansion. Okay? Yes, one more. Okay, so from here, we can find the first 5 terms. We need to find the ascending powers of x, and then from here we are able to find out the various terms already. So we have found out how to find the n term, that means the specific term itself. We have learned how to do the expansion in terms of ascending powers of x and descending powers of x. Then in this case, there's sometimes they will tell you, oh, back to there's some terms, and then they tell you that it is a co-independence of x. Okay, now let's talk about this term, constant independence of x. Okay, but before I go into that, I want to explore a bit more examples that we need to use to bring it in. Okay, so just now we have 1 plus x over 9, a to the power of 9. We got 2x plus 3 to the power of 7. Pretty simple. Okay, however, we also, like I said, this a and b could be anything. The x right now you see are linear, they are numerators, so it's x over 1, it's pretty convenient. What happens if it's 1 over x? What happens if it's x squared? It is the same thing as well, guys. Don't get freaked out if you get things like this. Okay, let me show you how. For example, they say it happens as well. Okay, so in this case, instead of now the term itself has an exponent. How? The answer is the same. See it the same way as it is, and you will not go wrong. Okay, let me show you how it works. Same thing, first term. If I choose 0, put the first term in, 2x squared, then 5. As it is. Then 1 to the power of 0. Okay, 0. Okay, maybe I don't use 0. I use something that is a number that you can actually see. 3. More calculations are involved, yes, but once you understand the general term, you can always use back the general term to plug in, no matter what numbers they are. It doesn't matter. Okay? Okay? So as we continue, I want to maybe go for in fact for this one, I can really expand everything because there are only 5, right? 5 means there are only 6 terms, not difficult. Okay? But let's just, for simplicity's sake, let's just focus on 3 terms. Okay, so this is the first one. This is the second one. 3 to the power of 1. Okay, then I put it at the bottom. 5 choose 2. You see, I'm just using the exact same things all over again. There's nothing new for me to change. It's just changing the number, either 1 up or 1 down. Just like that. Okay? Then we go and expand. We understand that once we got through the expansion part, like I said, always spend one more line to write down the numbers individually first before you add everything together. Okay? That is always the best way to do so. Okay, so same thing, 5 to the power of 0, and where is my pen? Okay, here. Okay, so I'll get 32 x to the power of 10. Okay, so here is 5, 2 to the power of 4 is 16, x to the power of 8. multiply by 3. A lot of things, right? Keep it there. Don't put them together yet. Wait first. Okay, then I go and do 8 choose 2. 8 choose 2, 28. 8 choose 2, 28. Okay, 2 cubed is 8. Okay, x to the power 6. Then I got 9 at the back. Then plus, this is a, oh no, it's like 5, oh it's 5 choose 2. Sorry. My handwriting brought the down on me. Okay, 5 choose 2, as we have seen earlier in our previous example, 5 choose 2 is 10. 5 choose 1, 5 choose 2, 5 choose 3. 5 choose 3 is also 10. So 2 square is 4x to the power of 4. Then this is 27. Plus top. Okay, so let's continue from here. Now we got all the numbers laid out. It's time for us to put in to multiply all the coefficients together to give us what we are looking for. So 32x to the power of 10, 80 plus 3, 240. Okay, this is 10 times 8 times 9, 720. Plus 27 times 4, 80, 28, 108. So it's 1080 x to the power of 4. This will be my answer for the first four terms. First four terms. Okay, first four terms. I realize my YouTube is lagging. Is that true? Oh, my YouTube. Wow. I wonder how long is my YouTube being. Wow. That means my YouTube cannot use really. Oh my goodness. This is bad. I see if I can do some magic here. Oh, this is a hang one. Remove. Yes. Oh, my YouTube capture has been hanging ever since, and I didn't see it. Ah, that's my bad. Not a very good live this time. Never mind. I think it's captured on Facebook, so I can maybe just do some I can just create it over there. Otherwise, no choice. I have to leave it like that. Okay? So sorry for those people who are using YouTube to watch. Okay, yeah, then front cam. Yeah. Okay, let me just try to continue from here. I try to do whatever I can. Okay, I try my best. I really try my best. Okay, so anyway, we are coming to the end already. Alamak. Okay, but like I said, I try to do what I can. Okay, so I already got the first four terms of the equation already. So you see, even if the terms is x squared, even the term is very ugly, it doesn't matter, because ultimately you will still get you'll still plunge it into the same general term and then expand each term slowly as it is. You will get it already. Okay, the last type of questions is when we have the first part, when they ask you to go and expand this, and then they will go and ask you to compare with another coefficient or another expression, and then they tell you that, oh, the x squared term, the constant is something, find the unknown value. Okay, so if you guys are looking for deeper explanation into those, then you guys can feel free to pop these questions to me in my various community chats, either my WhatsApp groups, my telegrams, or my Discord servers as well, or y'all can come into my weekly quickfire to ask as well lah. Okay, so I'll just hang on so I'll just okay, so in that's the case, I will just end the live stream here today. It's 8 o'clock already. So we covered a bit of binomial theorem. We talked about Pascal triangle, and in this Pascal triangle we talk about the binomial theorem, how it works, the general term, finding the specific term, and then expanding for the first few terms. Expanding, we are talking about both ascending powers of x and descending powers of x. And then we also talk about finding the value the value of specific n. You also understood what is n choose r, that means using the notion of factorials. Okay, so all of these terms serves as the basics of binomial theorem. So if you guys are looking for more of such sharing and tips, you guys can actually come over to my Zoom every week on Thursday 5 p.m. to 8 p.m. So apart from that, join my Discord server, my Telegram channels. Instagram wise, I will release the links onto my Telegram channels and Discord and my other platforms lah. So y'all can go and like and follow. I haven't been posting a lot over there, so I'm still trying to structure a bit of a content. But maybe starting from this month onwards, I'll be posting more content to build up for the exam boot camp in the June school holidays. Okay, so that will be all for today. So thank you guys and see you guys next week. Bye.